So good afternoon and welcome everybody to this weather briefing. It's sunny Monday in Zagreb, and as you can see on the first slide, we have some clouds, but we don't feel them. It's really like springtime in Croatia. Today we're going to do a weather briefing from National Weather Service of Croatia, and my colleague Tanya and me will give you the overview of the weather today, some time ago, and in the near future. You can see a small fly here, and why I put it there, because this morning I woke up and I killed two flies, which is really something strange for the mid-November to see flies buzzing around. So first, Tanya will give you the weather analysis, and I will talk some more later. Tanya, go ahead.
Hello everybody. Just to shortly introduce myself, my name is Tanja Renko and I work as a senior forecaster at the Croatian Met Service for 10 years now. We will spend a little time about weather currently in Europe. Then I will say something about weather that was in last 2 weeks. We will talk a little about low clouds and fog over the Adriatic on last Friday, and then even we'll continue with what RGBs are the best for diagnosis of fog, and he will show you a very interesting case study from 17th of October when we had hail and then fog. Hail from fog. In most of the morning there was fog, and in the next synopsis showed hail in the town of Osijek. This is eastern part of Croatia. I will now jump to the current weather situation. As you can see, there is high pressure present over southern part of the Europe, over most of the Mediterranean region, and unusually high temperatures prevail over the biggest part of the Europe. Northern parts of the Europe are under cold air masses, and a deep low is now passing north over the Scotland. A big pressure gradient are present between these two systems, and strong westerly and southwesterly flow is present here over western and northwestern Europe. So some countries issued warnings for wind, especially on the coast, for example, Great Britain and Netherlands. These two systems are also nicely visible and on the next slide, where I presented the height of pressure level of 500 hectopascal overlaid over infrared image, and so you can see this extensive low over here and the high pressure situated over Mediterranean. Also, we have two disturbances in the east, and this one in the Middle East is producing thunderstorms. And I must say that all of these images are from 06 UTC this morning. Jet stream that is separating these two air masses will push all the disturbances in the northern part of the continent in the next days, and this high pressure field situated over Mediterranean will persist, or I can say it will stay untouched until next weekend. What is interesting, after more than, we can say, 3 weeks of unusual warm weather in southern part of the Europe, for next weekend, deterministic model, the deterministic run of ECMWF show us a cold air outbreak, and this cold air outbreak will result in snowfall in the parts of the Europe that was having unusual high temperatures most of the month. So we have very extensive trough here over the most of the Europe. We have cold air that will go in the southern parts of the Europe, and it will be very interesting weather next weekend. But of course, we must have in mind that this is deterministic output, and we must also look for ensemble forecast. But what I want you to show you also is EFI, Extreme Forecast Index, for today and for Friday. You can see that on the upper chart, where this is EFI for today, there is a signal for unusual warmth in most part of the southern and middle Europe, but this warmth will be shifted and will be reduced on Friday, and the signal for the colder than usual is now more pronounced of the north of the Scotland. But as EFI is only produced for 5 days ahead, this will be something what will be interesting to follow in next days. Also, if we look to ensemble prediction, this is a plan for Zagreb, so for continental part of Croatia. We can see that the signal for lower temperatures for Saturday and Sunday is quite consistent. Also, there is some precipitation, and already we are talking about the possibility of a snowfall. And today in our forecast room, we made a bet on what will be the snowfall measured on Sunday morning. And here you can see the table with our bettings. This is the snowfall amount for town Karlovac. Karlovac is picked up because Ivan is from Karlovac, and this is the maximum snowfall in Croatia, and some numbers are put here by names, and so the one that we will win, he buys or she buys a drink for everybody else. Okay, so I will now say some words about November. November in Croatia, as I already said in an introduction, was very warm in most of the parts of the Croatia, and in this table you can see that some absolute maximum of temperatures were exceeded this month on 9th of November, and these are previously absolute maximums for some towns. Also, what is interesting is to see the number of installation, which is given in hours, and in some parts of the country, this graph is for Zagreb. You can see that the amount of the installation in November was really great, big. So even it was greater than ever in some parts of country. On the left, this is a graph that shows installation from the beginning of the year 2015. Also, on this slide, I can show you that average temperature in Croatia in 15 days is mostly 1 to 3 degrees above normal. And what is even more interesting is these are the numbers for mountainous stations. This is a mountain near town Zagreb, and this deviation is 8.3 degrees. This is Station Park, and this is Zavežan station. So this deviation is even more pronounced in mountainous regions, and this is some kind of usual in this colder part of Europe when you have warm advection and you have sunny weather in higher parts and sometimes lower cloudiness and fog in the valleys, and because of that this is more pronounced in the temperatures in mountains. Also, what is interesting to say that there was no precipitation in November, so zero precipitation, and just to make a short summary, we had really warm 16 days in November. Today is also quite warm in Zagreb. We have 18 degrees now with sunny weather and no precipitation. So we are already looking forward to some precipitation next weekend. Especially it will be snow. I would just want to show you some slides from last Friday, 13th of November. You can see that most of the Adriatic was covered with a low clouds, fog stratus, and on the here is the verification of temperature measured in town Rijeka, which is situated on the coast. And as you can see, these violent image dots are measured temperatures, and these are temperatures that were given by a high resolution model. So you can say that this forecast temperature was really overestimated. And this kind of situation with the fog or low clouds over the most of the Adriatic region is more common for spring, but also it can happen in autumn or in November. And for most of the towns, average number of day with fog or low or fog in the coast is 1 day per year. On this slide, you can also see that in most of the parts of the coast there were fog and low clouds. So this is just to show you what some models gave us for Friday for 6 UTC. On the left side, you can see ECMWF here, and this is high resolution model Aladdin. There is some hint for low clouds and fog, but I would say that this was not good enough. So forecasting fog is very difficult most of the times, and I hope that you agree with me. And I will now, Ivan will now take his part on RGBs that are useful for detection of fog and low clouds.
Okay, thank you, Tanya, for a nice screening of the weather in today and the past actually 3 very warm weeks in Croatia, and I guess it wasn't so warm and so stable in the northern parts of the Europe. Some in the audience can confirm, I guess, this. But yes, it was very stable, and of course, fog is associated with this kind of weather. And I will just give you a short and a quick scanning through the RGBs, which you can maybe use to identify fog. And I'm starting with one of the maybe most used RGBs in our operation room for fog detection. And I see some of you already picked up the idea that I had with all these channels that are listed on the screen. So if you can place the star on any kind of sign over the channel you think we use to do this combination. This is not standard RGB from the list of the well-known RGBs, but we did it for our own purposes here at the Institute in our forecasting room. So I see few more votes. 8.7, 2.2, HRV, visible 0.8, 0.6, 3.9. Okay. Okay, I'm quite happy with the answers so far. And the answer is, I'm sorry, I give you here. It's near infrared 1.6 on the red beam, on the green beam high resolution visible, and also on the green beam high resolution visible. So I just wonder what made you think to choose the channel. How did you how did you mostly guided your thoughts towards particular channels? Okay, from resolution, I see many of you. Of course, high resolution is distinguishable from normal resolution. So it's 1 kilometer versus 4. I would say in Croatia, four by 4. Uh, I probably see Natasha is laughing and she just knows she's in the audience as well. I think she produced even this RGB. So no, okay, somebody else. Good, even better. Yes, few valid answers. We call it fog RGB, and why do we use this one? First of all, high resolution, which is very good to depict the boundaries and the shapes of the RGB of the clouds. Second of all, there was an answer somebody gave microphysics as a hint, and if you take a look at this part of the slide, you can see that we have some high cirrus clouds which are bluish, actually cyan color, and also we have some peaks of the alpine mountains that are covered with snow. So and here the clouds are whitish. So what that would mean, it's the phase that is picked up by 1.6 channel, which gives you more reflectance over water phase particles than over from the ice particles. So clearly you can see the difference. Maybe here in this region there are some bluish parts which could be mixed phase small ice particles over the warm particles. What else is interesting to see are the shapes of the clouds. You can see the optical thickness, thinner or thicker clouds. In this image there are two interesting dots here, and if you can pay attention here, my hint was this morning when I saw these two dots, I thought it's a this trail cloud effect. Well, when the plane punches the cloud and makes the hole, but this occurs even in the higher clouds. And also here is one black dot, which is also considered to be just a hole in a cloud. So I produced a small animation which consists of few slides, and I will just load them quickly for you. I hope you can see next slide. If you don't see the incoming slides, please let me know. So the loop is from 11 to 12 UTC, and okay, this is the last one. So if I go back now, it should go faster for you. You can see that the lower two dots, they are moving, but this one not. So if I go again, so what is the difference between these two black dots and this one? Is that actually this one is hole in the cloud, while the thin cloud or no clouds below is the water surface, which is absorbing the visual spectrum of the sun and doesn't reflect back to the satellite, so therefore is black or darker. But these two dots, they refer to, I don't know if you can see them, but there are two thin cirrus clouds, or maybe a bit thicker cirrus clouds, which cast shadow to a lower cloud. So it is quite useful, therefore, to take the fourth dimension, or the third in this case, because it's kind of two-dimensional. Take the time and make the loop. So you can do some better analysis of the clouds. What is also interesting for fog detection is, of course, the progress of the cloud formation or dissipation. So always when you look at the fog, please consider a few consecutive slides or times just to see how what is the progress. And in this case, the fog is dissipating in the Po Valley mostly, but also in the southern Adriatic. As you can see, if I go back to the first slide, then you can see clearly dissipation. And also, of course, now when I do it quickly, you see that most of these patches are actually the high cirrus cloud. They are not the mixed phase of the fog and the low cloud, but it's high cirrus which moves over the fog. Okay. Second similar product that we use. Can you guess now which would be the channels for this one? So the first one was microphysical channel 1.6, and two beams were high resolution visible. Can you guess now and vote for the channels that are used in this RGB? HRV, high resolution visible channel, of course. You can see that the resolution is better. 2 votes for 10.8. Okay. Any more guesses? No. Okay, 3.9. 3.9 is a good channel. It's better microphysical channel than 1.6, but it's not used in this case because it is dependent on the solar and the thermal component. Okay, this time it's not 3.9. This is, we call it HRV Cloud RGB, and I don't give you the recipe, but the recipe is HRV, and on the red beam instead of the 1.6 microphysical channel, we use 10.8, which gives you the temperatures. So if you compare these two images, if I slide from one to another, you can distinguish low from the high clouds, but in the first case you distinguish it by a phase, and in the second case you distinguish by a temperature. So you can see in this case you cannot distinguish between snow and the ice clouds, but in the previous RGB you can see that these are the same phases of the clouds, of the water itself. Okay, so if we move to the last one, I give you the near natural, we call it near natural, and here, if you can vote quickly, this one is also quite similar, and if you think of the previous two, yes, high resolution visible, definitely. Near infrared 1.6, 10.8. Yes, of course, this one uses all the advantages of the microphysical and the temperature information from 10.8 in a RGB collection. Okay. So standard set of, just to go to the standard set of RGBs that are much more poor for, especially if you want to have a regional view into some of the cloud patches. Croatia is not so big country, and our regions are small, and if you're gonna do a forecast or analyze of the fog in some region, you really have to go to higher resolution. If you compare these two images, they do not overlap, but this one is standard resolution of severe instrument, and this is actually the high resolution, so you can really see the difference there. Natural color RGB, you see it's similar to the first one. It has 1.6 channel to distinguish between phases, so ice or water, and 2 visible channels instead of 2 high resolution visible, so 0.8 and 0.6 on the green and the blue beam. Next one, air mass RGB. As you can see, it doesn't give you much information about fog. Why? Simply because it uses mostly channels, water vapor channels 6.2 and 7.3, which gives you the information about the water content on the mid and the high troposphere, and therefore you cannot say much about the what's happening on the ground. Next one is dust RGB. This is the combination that gives you in the red, green, and blue beam, gives you in the red brightness temperature difference between 12 minus 10.8, in the green 10.8 minus 8.7, and the blue gives you the temperature with 10.8 channel. But what this means, it gives you somewhat the phase and the temperature of the clouds, but it doesn't give you really strong information. Here in this product you can see fog. You can distinguish between the bare grounds, but the difference is not so big and not so pronounced simply because microphysics and temperature is not so well depicted. Similar would be 24 microphysics RGB with a different tuning. It's almost the same product. Okay, moving on, and that would be maybe the weapon of choice, day microphysics, of course, during daytime only. On the red beam, it uses visible channel to give you the depth of the cloud. On the green beam, it uses reflection of 3.9 channel. Reflective component, which gives you the phase and actually the size of the particles, information about that, and the blue beam would be the temperature. So if you consider low clouds or fog, of course, with the satellite, it's almost impossible to say if it's a low cloud only or a fog if it touches ground, because it sees the cloud from above. So all the low clouds, stratus or fog, is depicted in whitish or bluish color, depending on the particle size and the optical thickness, but the range is from light blue to over the whitish to a bit yellowish colors for the fog and the low clouds. And you can see it's clearly distinguishable between mid or high clouds, high cirrus clouds in this combination. Okay, and just for the end, I will give you a very interesting and quick case that happened in Croatia actually last month, but it's connected to a fog and the time and the season that we are in. And it's the case from the 17th of October, and it happened in the eastern part of Croatia. And you can see what happened is the core of the thunderstorm cell, well, the CB cloud, and this is convection RGB, which gives you in yellowish or whitish shades, gives you the core of the most intense part of the cloud. In yellowish color, which comes from the green component, and that it is 3.9 channel, which gives you the information about small ice particles in the intense updraft. So here you can see the convective cloud. I will not show you the whole loop, but what happened, the small convective line moved from the morning. In the morning here, the convective cell generated, and then moved quickly towards the east and passed over town of Osijek, which is around here. This is just due to the inclination of the satellite, the shift of the image, and it moved to the western part of Serbia. So this is the border between Croatia and Serbia. So it was actually a small scale thunderstorm with a small cell, convective cell, and here you can see the I will not take more of your time to vote on this one. I will reveal the secret. It's the combination of the high resolution visible and the day microphysic RGB. I just put high resolution visible in transparency, so it looks like this. But why is it so helpful? Because it gives you the position of the cell according to the shades from the sun. So the sun direction was from here. This is noon. No, it's 10:20 UTC. It's just before noon in Croatia, and the sun direction coming from here. And also, what you can see in the white shades, as I explained before, in day microphysics, you see the low clouds. In our case, in Croatia, in eastern part, it was mostly fog. It was an intense, as I said, system. The temperature on top of the cloud depicted by satellite was, so to say, only 234 Kelvin. In well-developed cases of the very severe thunderstorms, the temperatures on top of the cumulonimbus clouds can go well below that. But it, however, produced a lot of hail in the town of Osijek, and this is the image from one of the streets there. I have a video, but unfortunately it would take a lot of time to upload. But it was quite impressive to see that the hail is falling actually from the fog, and it's a very rare occasion that something like this happens. However, the hailstones were very small, and at the end it looked like snow was falling on the ground. Okay, I think that was my last slide. A lot of fog, but this is the season of fog we talked about. I will thank again Tanya for her part. And I will just, before I say goodbye, I will turn the last slide actually, and this is the announcement for the next weather briefing that will happen in almost 1 month, and it will be hosted by the Austrian Met Service, by Andreas Wirth and Lilian Hoff. Thank you again for your attention, and see you in 1 month.